Guys, welcome back to another video here from the Off-Grid Garage in what can I say? It is sunny, hot Australia as you know it. Probably not. Well, this morning we had some rain and now the sun is back in full force. We have like, what did the sensor say? We have 78% humidity inside the garage here. It is almost unbearable. Yes, we will have an air condition in here at some stage, but unfortunately not at the moment. And I don't have the portable air condition anymore. Look at this. I just turned on the air condition in the Tesla half an hour ago and there is a river of water. I hope this is not the new norm for us with all this climate change happening and we are seeing these super humid summers now. Because usually summer is super dry here. 40 degrees, no sweating. 20% humidity only then. It is hot but dry. But now it is hot and humid. It is like on a tropical island. Anyway guys, we are back in the garage. In yesterday's video we have installed the new JK BMS. This is the 100 amp version with a 0.6 amp active balancer. And the reason I chose this BMS, I want to find out if this small balancer is actually capable of keeping the battery balanced. I think it will be, but we want to see, test and find out. Okay, so in today's step we want to take off all the glasses again and install the PITA boards. We have three PITA boards here, a JBD slave, a JK slave, and we also have the JK master over there. So the master will go all the way down to the new JK. This will be our last point in the chain of PITA boards. So I have already isolated our old JK BMS here because I want to take out the balance cables to turn it off. So and here's our PITA master board. So and instead we are installing the JK slave. And we plug in our balance cables again. And magically the JK BMS starts itself. First generation BMS usually needs a 5 volt between B negative and P negative. But for some reason with the PITA board connected it just starts up automatically. Okay, turn it back on. All good. And we do the same down here with the new JK BMS. Isolate. I probably don't need to isolate it. Okay, turn off the BMS. And we are now installing the PITA master board. Alright, turn it back on. Turn on the breaker. All done. Last one, JBD. So here with the JBD, unfortunately, we have to disconnect the Bluetooth module of the BMS and connect the PITA board instead. See, the PITA board has actually 2 connectors here, and I know PITA was experimenting having the Bluetooth module connected to the second port again. But for some reason it didn't quite work. So hopefully this feature will come and we will still have Bluetooth access to the BMS if we have a PITA board connected. But for now it is either Bluetooth or the PITA board. So we want to do one last check with the BMS here with Bluetooth. I'm sure the settings are all correct, but just one last glimpse. 280. See, we need to 304.123 BMS right. So cell full voltage 3.45, cell minimum voltage 2.8, discharge and capacities. See, all these voltages here, they are not really relevant. Only if you connect the BMS and it has not been calibrated. It takes these voltages here to make an estimate how full the battery actually is. So this is actually more interesting if you frequently disconnect your BMS from the battery. But here in this case, we don't use the voltages at all. Balance start voltage 3.45, delta 5 millivolt. Balance only when charging is off. So we are charging when the battery is idle. 45, over voltage 3.65, under voltage 2.5, 110 amps, charging, discharging. And this is the short current 380 amps. Okay, that is all good as far as I can see. Now you can turn off the BMS, disconnect the Bluetooth, and connect the BMS to the top port, which says JBD overkill underneath. Okay, turning on the BMS again. Nothing is happening because the board needs a 5-volt input signal to actually run. There's no power coming from the battery directly to the PIDA board, like with the JK BMSs. They supply power directly to the PIDA boards and they just run by plugging in the cable. Not the case here, unfortunately, so it needs an additional 5 volts. So at the moment I'm still a bit unsure how to mount these PIDA boards here in the case, but for now it's only testing for a couple of months. So I leave them just hanging around here, but eventually I probably mount them to this support beam here in the shelf on here. And I've got another cross beam here where I can mount it. And also it sits over here like this. I just print something in 3D and then we can have it mounted like here so it looks nice. And down here I can mount it on the aluminium bar next to the breaker as well, somewhere over here. Oh, what's going on here? Oh. There's something wrong with the cabling. Ah, God, come on. Yeah, if I pull on the positive and negative going into this micro JST connector, the board comes on and off. So something is not right here. I'll just disconnect it again and have a look at the connector. I think it's the positive, which is not... it doesn't seem to be the negative, but when I move the positive up and down, it disconnects. Okay, I have to check these micro tiny... damn it. Yo, I found the problem. You really need to push in this STC connector into the port as far as possible. I have used a small screwdriver and pushed on the plastic left and right, and it went in another millimeter, and now the cable is not moving anymore as it did before. It was a bit loose and I could actually move it up and down inside the connection, but now it's solid. My mistake. Yeah, perfect. So I've now connected the first LAN cable here to the JK master on one of the sides. It goes up in the next shelf, and here it connects to the JK slave number 1, just like this. And now we need another cable from here. Plug in this. And this now feeds through to the next level up there. And here it plugs into the next slave. And then from here we use the green cable, which goes to our Raspberry Pi. I want to plug this in. So, and now we feed a USB-C cable next to our LAN cable, and this plugs into a USB port I have here in the top compartment. And here we connect this to the PIDA board. We get a light, and we can see the blue light is flashing straight away, so there is communication with the Raspberry Pi. Oh, this cable mess here I don't like at all. Okay, so blue light flashing. Blue light is flashing. This is dangerously close to the negative of the battery. And we have no communication down here. Hang on. Press the button. No comms. Why is that? Is it maybe plugged into the wrong port here? There we go. Okay, obviously, I remember Peter said something about these 2 ports here on the master BMS, and you should use only one. It may work with the other one as well, but in my case it didn't, so I swapped them around, press the reset button here, the ESP starts up, and everything is working. Yeah, definitely have to have some protection here. If the board moves and touches a negative with one of the pins here, that's the end of some electronic here in my shelf. Okay, that should solve the problem. So I've isolated here the bus bar and also fixed the cable down here so it cannot actually move forward now. It's a bit, because of these stiff LAN cables here, it moves around a bit, so I really need to design a holder for all these boards if I keep them for longer. There's nothing it can touch, everything is plastic around it, so that's all good. I just want to see the LEDs here, like on this one, which is upside down. There you go. Electrical tape fixes it. Oh boy, this is not the new standard, believe me. It's a temporary setup. Don't leave any nasty comments about the electrical tape. Okay, JBD slave, JK slave, and JK master. All flashing. Okay, the BMS already shows up here in the Victron remote console. We still have 30.6 degrees inside the garage and 74%. So now the only thing we need to do is connect to the BMS interface slave 1 board using the password 123456789 connect. Okay, it connects, web page not available, that's fine. So we have to go to 192.168.4.1, enter, and we log in with BMS, and the password is CAN, C-A-N, all lowercase, sign in. And we should see the configuration page, and we have to do this because we have never connected to the JK slave PIDA board, and we want to connect to the network here, password, and it says the ESP will now try to connect to your network, please give it some time to connect. And I'm sure if I go into my Home Assistant, I can already see the third board now popping up. There is already a yellow dot, it says notification. New device discovered, check it out. And this should be the JK BMS interface slave ESP home. Perfect. It automatically integrates into Home Assistant immediately as soon as it connects to your home Wi-Fi. How good is that? And all the information, how to connect to the board, how to set the password correctly for your Wi-Fi, this is all in the BMS interface board instructions you get with the PIDA board. First look in the Victron VRM, and we can see the JK BMS interface down here, which gives us the combined information of all 3 battery banks now. We go into settings and have a look all the way down here. There's the JK interface board. We go into device, we go into name and call this one the PIDA board. Otherwise, if I call it the JK BMS interface board, nobody knows what it is. Okay, here's now our PIDA board. It gives us the state of charge, reported by all 3 BMSs together, and then aggregated and sent to the Victron system. The battery voltage and the battery current. Going into details. Oh, interesting. It shows us the battery number and also the cell number now for the lowest and highest cell, as well as the temperatures. Battery modules, we have 3 online. And the installed and available capacity is wrong. So there's still a bug in the software, it doesn't show us the full capacities here. I assume it only shows the master BMS at the moment, but not the capacity of the other BMSs. Yep, we got all the alarms here, there's nothing at the moment. History gives us our discharge energy and our charge energy. I think this is for today. But I'm not sure if this is only for one BMS again, for the master maybe, and not for all 3. I have to find out or have to ask Peter. Here in the device options you can rename your board if you want to. You can see the firmware version your master BMS runs, I think, and the VRM instant as well, 512 here. And the parameters, here we are. So it sits on 55.2 volts. On a CCL of 300 amps and a DCL of 300 amps as well. So, and these values we can change easily now with the mobile phone, either by going to the dashboard website of each individual PIDA module, or we can use Home Assistant and just drag the sliders across and change these settings here on the fly wherever we are. So let me show you this, how it looks like in Home Assistant. Wait, before we do that. So at the moment, the PIDA boards are monitoring each individual BMS, sending all the data to the PIDA master board down here. This reports all the information back to the Victron system. So this all works perfectly fine. As you could see, it is just a plug and play solution. You plug everything together, connect them to your Wi-Fi, and you're good to go. So at the moment, these PIDA boards are not controlling anything in the Victron system. This is still being done by the Victron Smart Shunt, and the JK-BMS, the PIDA boards here, they run in parallel in a, so to speak, shadow mode. So they're monitoring, reporting, but not controlling. And in the Victron system, you can easily change the control mechanism from the Smart Shunt to the PIDA boards now. I just realized the PIDA board actually shows you the password of the BMS in clear text. So if you have forgotten your password of the JK BMS, PIDA board to the rescue. Okay, so we are back in the Victron remote console, and the nice thing is now we've got the PIDA board and the Smart Shunt next to each other. So we can see actually the difference at the moment because the PIDA board is still uncalibrated, but the voltage is fairly equal now, and also the current. You can see it's almost identical. It goes up and down a little bit, I guess depending when these devices are measuring the current. So far it looks really good. So at the moment the Smart Shunt is still in charge of controlling my whole system now. We want to change this and give the PIDA board the control over the whole system, setting the charge voltage and the charge current and also the discharge current, which is not so much of interest for me because I'm off grid anyway. Okay, we want to go into settings and go into the DVCC, and here we can see the controlling BMS. There is none. Yeah, we can go in here and we can give the PIDA board full control over the charging. Okay, let's do this. And we can also turn on DVCC, but we don't need to anymore because we can control everything through the PIDA boards now with the help of Home Assistant, or you can use the web interface of the PIDA boards as well. So we leave this turned off for a moment. So we also want to have a look in the solar charge controllers, network operation, and we can see here it is a slave of the BMS now. So it has already switched all my solar charge controllers now to listen to the BMS and not to the Smart Shunt anymore. That is pretty cool and scary. So if we now go back into the Victron VRM, we can still see the PIDA board is down here as a secondary device. It is controlling our system now, but it's not the battery monitor. The battery monitor is still our Smart Shunt. So to change this, there's a second config we need to change. We go back into settings, we go into a system setup, and we can change the battery monitor from the Smart Shunt to the JK BMS at CAN bus. Why is it not called PIDA board here? Okay, and that's it. So if we now go back to the VRM, we can see the Smart Shunt is now the secondary measuring device, and all the data showing up here now in our battery monitor is coming from the PIDA boards, collecting all the information from all three different BMSs now. And here it is also adding the battery temperature now, 36 degrees. And we will leave the Smart Shunt visible here in the Victron VRM, so we can monitor and compare all the data, all the values between the PIDA boards and the Smart Shunt. And in the same quick manner, you can switch back from the PIDA boards to the Smart Shunt again and make the Smart Shunt your battery monitor and also responsible for the charging and discharging of your system. So it's very easy, very quick to do. So we just go back into the PIDA board and have a look at the parameters again. So we are on 55.2 volts and 300 amps charging and discharging. So I'm starting my Home Assistant, and here on the main dashboard. And here we are looking at the JK interface master. The absorption voltage sits on 55.2 volts. So if I move the slider here on my mobile phone and set this one to 56 volts, 56.5, whatever, we can see it changes it here in the Victron system as well. And now it would tell all the solar charge controllers charge to 56.5 volts. So you can control your whole battery, your whole system from your mobile phone via Home Assistant now. And this is, as you have seen, it's a fully automated integration. There's nothing to install, nothing to script, nothing to code. It recognizes the PIDA boards automatically once they are connected to your network and says, hey, I found a new one. Do you want it to integrate it? You click yes, and you get all the information, all the data. It's 120 odd sensors from each of your BMSs. And if we scroll down and have a look at the JBD interface slave board, we've got a charging count of 100 amps. If I lower this one to say 50 amps, it will change the CCL from 300 amps to 250 amps. Of course, this does not mean only 50 amps go into the JBD BMS and the other 200 amps go into your remaining battery. This is nothing we can control because the batteries are all in parallel. And depending on the internal resistance, state of charge, temperature, all this kind of stuff, they take as much current as they need. But we can tell the system to slow down. So if I change this back to 100, we will see here it goes back to 300 amps as well. And you can do the same with the discharge current as well. If you want to set this one to 2 amps only, it goes down to 202 amps after a moment. And even the JBD and all the other slave PIDA boards are showing the absorption voltage as well. They are not functional. Yeah, if I change the absorption voltage here to 54.1, it doesn't change it here in the Victron system because only the master can change this setting. And there's also a new firmware update available for your PIDA boards, which actually disables all these functions here on the interface website for this PIDA board, as well as here in Home Assistant. So the absorption voltage for the slave BMSs will not show up anymore, because they are not functional anyway. And the very interesting thing now is, you can see it here in the interface master board. There is a switch behind it. If we starts raining, can't believe it. If we turn off the master, have a look at the VIM. It disables charging and discharging altogether and also sets the CVL, the charge voltage limit, to 54 volts. Yeah, this can act like an emergency function. If you are not at home, something happens, you press this one button and it turns off your whole system. From a battery perspective, of course. I haven't set this all up correctly because the PIDA boards were only shadowing the system. But now, as they are in charge, we need to set the correct values. So here 55.2, and we set this one here 1.6 down, which makes then 53.6 volts, which is our float voltage. Look at this. Rain again, and I'm sure behind the clouds there will be sun again, and it will be hot and muggy afterwards again. At the moment it's pretty nice actually. It has cooled down quite a lot. The air is much nicer and crisper. You select all your information you are interested in. Really trying to make a video here. The storm has passed. Alright, back to the Home Assistant. And the charging algorithm here and the PIDA boards are absorption voltage 55.2. We're charging up to this voltage, staying there for 30 minutes, allowing the BMS to balance. And then we fall back by 1.6 volts. And this is exactly 53.6 volts. And here we would stay for 6 hours in float mode. And after that time, the BMS would reset and start a new cycle. Would recharge to 55.2 and the whole thing starts again. We also have a charging manual button here. When we turn this one on, the PIDA board will then tell your inverter to charge to 55.2 volts and stay there forever. And the background on this one is it gives the balancer a long time to balance your battery pack. That's why it says top balance in brackets behind it. This is a manual top balance function. You charge to a bit of a higher voltage, let the balancer balance your battery pack, and then you turn off this function again and everything goes back to normal. So whenever you see your battery is not balanced anymore, you hit this button here and it will fully automatically top balance your battery without you doing anything. And then afterwards you turn this function off again until the next time. So this could be a maintenance routine for you then for say once or twice a year depending on your battery. And you don't have to connect any external balancers anymore. I have to take the battery apart and put all the cells in parallel, or manually charge and discharge single cells. No, this is all being done by the Peter board now. Okay guys, I have shown all this functionality already in a previous video about the Peter boards. So if you are interested, I'll link this down below as well. There's also information under this video where you can order these boards. At the moment, they're compatible with the JBD, the Overkill, and the JK BMS. Yeah, and I guess we will test them for the next couple of months here in the off-grid garage. We have now connected them to all 3 battery banks, and then they are in control of our charging. So I'm really keen to see how this works out over time. And I guess there will be a video here and there about the Peter boards and how it performs with our system. So hopefully we can fully charge tomorrow, and I can show you how the Peter board handles that and how it controls our charge controllers then. The AC coupled solar we have installed on the house, the tilt system, is still controlled by the Multi-Plus. So this will not be affected by anything we have done here so far. The Multi-Plus is taking care of the AC coupled tilt system. Okay guys, so far this video from today, installing all these Peter boards here and connecting them all, configure our Victron system, have a quick look in Home Assistant, how this all looks like. Thank you very much for watching. Thanks for all your great support here, for all your amazing donations. Thank you very much. It really helps and makes a big difference. And until the next video, guys, when we have a look at the JK BMS. Apparently there is a fix for this whole situation. Until then, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. Yeah, and the data you are seeing now in the Victron VIM is coming from the Peter boards now. This is not the Smart Shunt anymore. The Peter boards are in charge. It's pretty cool.